Good afternoon, students. So yesterday we already discussed about the types of chemical reactions, right? We already discussed about the types of chemical reaction, and we discussed about the first type, that is the chemical combination. When we say combination, means we combine two things, right? So chemical combination. I already discussed this. So in today's topic of discussion, we will discuss the second the second one, that is the chemical decomposition reaction. Okay, the second one, which is chemical decomposition reaction. Now this chemical decomposition reaction is also known by the name chemical decombination reaction. When we say combination, it means combining two things, but when we say decombination, means to separate one thing into two or three more things. Okay, decombination means to decombine them, to separate them. Decomposition also, when we say decomposition, right, decomposition of food materials means to make a bigger food material into smaller food materials, right? Therefore, in chemical decomposition reaction also, what happens? A big thing is made into smaller things. All right. So here, first you have to understand the basic definition, which I already told you. What is it? It is decombination, which is separation or decombining. All right, so the definition from the book here is written that when a chemical compound decomposes on heating, okay, on heating, heat is required here. In this reaction, heat is required. Okay, so without heat, there is no decomposition, there is no breaking down. Okay, so heat is required. When a chemical compound decomposes on heating or absorbing some kind of energy or taking in, okay, see, heat is required because it takes in heat, all right, or it takes in some kind of energy. Okay, so as to form two or more elements. So from a big product, first it was AB, now we're getting two. This one was one, but now we're getting two, splitting into two. Okay, you understand? Decombination, splitting, separation, this big thing into two small things. Understand? Now this, because it is AB, right, it is a compound. All right, and since this is 1 and 1, these are elements or compounds. They can be elements or compounds. But this here, because it is combination of two different things, two different elements, it is a compound. Okay. So let's go again with the definition. When a chemical compound decomposes on heating or absorbing some kind of energy so as to form two or more substances, elements or compound, then the chemical reaction that takes place is called a chemical decomposition reaction or a chemical decombination reaction. See, check this one. In exams, they can ask you either what is chemical decomposition reaction or what is chemical decombination reaction. So both are the same. All right. So here also, what happened? You need the definition. This representation, that is AB, gives you A plus B. This one is a compound. These are elements or compounds. Then example. Okay, in example, I'll discuss to you. Okay, this activity 1.5. All right. So in activity 1.5 here, they're saying what? Okay, suppose you take a test tube, right? And there you add ferrous sulfate. Now ferrous sulfate it's like a salt kind of thing. Okay, it's a kind of salt, but it is present in, do you see in figure 1.7? See, it's present in pellets kind of form. Okay, they are like a rocky small rocks, right? But soft rocks, not hard rocks, but soft rocks in the form of salts. Okay, so here they're asking you to take that ferrous sulfate, about 2 grams. Okay, you measure it 2 grams and you take it in a test tube. Okay, then hold the test tube in a holder and heat it. This is a very important step. You have to heat the ferrous sulfate. Okay, just the ferrous sulfate alone, nothing. Just add ferrous sulfate, which is from the bottle. You add the ferrous sulfate, and after that you heat it. What was the important step? Heating. Right? So this ferrous sulfate, after absorbing the heat coming out of the flame, right? What happens to the ferrous sulfate? It changes. Okay, it takes a change. Okay, what happens? See the figure 1.7. Please check with your book. Okay, as I'm explaining. See figure 1.7 there. At first there was ferrous sulfate, right? But after heating there was small powdery substance. Do you see? Powdery substance. All right. Furthermore, right? First it turned into powdery, but furthermore on heating it will change into a deep brownish black mass. Okay, a deep brownish black mass. Right now, supposedly check figure 1.8. After heating, right, after this ferrous sulfate, which is green in color, I guess, is it green? Yes, it is light green in color. You heat it, it changes into a powdery substance, but then you want to heat it more, so you heat it more and it changes into a deep brownish black mass. After it changes into that, it releases a smell. Okay, it is a very pungent smell, a very strong smell. All right, and since you know that it releases that smell, then gas is evolved, that is gas is given out. All right, so what happens, see here in this example, FeSO4 dot 7H2O. Okay, this is ferrous sulfate, but ferrous sulfate is present in a hydrated form. It was not dried. Okay, it has a bit of water, therefore you wrote dot 7H2O. Okay, upon heating, right, you heat it, right, it forms into a, I told you, right, it forms into a deep brown deep brown black colored mass. Okay, that mass is none other than ferric oxide, right? It is what? Ferric oxide. Furthermore, I told you that you got a very pungent smell and gas was evolved, right? Those gases are none other than sulfur dioxide and sulfur trioxide. You understand? See here, from this huge thing, that is, this is AB, okay? From this huge thing, upon heating, you're getting three more things. So this is decomposition. This is separation of a big thing into three smaller things. All right. So that activity explains this example which I just wrote here. All right. I hope that is clear. Okay. So in chemical decomposition reaction or chemical decombination reactions, there are three types. Okay. That is, number one, thermal decomposition reaction. Number two, photo decomposition reaction, and number three, electro decomposition reaction. All right, there are three types. So we'll come to the first type, that is thermal decomposition reaction. When you say thermal, I already told you what is it. Why do you wear thermals during winters? To supply you with adequate amount of warmth, adequate amount of heat, right? So thermal here also means heat. All right, so the definition of thermal decomposition reaction is when a chemical compound decomposes on heating so as to form two or more substances, elements or compounds, then the chemical reaction is called a thermal decomposition reaction. Thermal means heat. Remember this, okay? Thermal means heat. Okay, so when a chemical compound decomposes, that is, it breaks down into smaller or smaller particles on heating, all right, then the chemical reaction is called thermal decomposition reaction. Okay, so I want you to read activity 1.6 on your own. It's very simple. Okay, just read on your own, understand, put yourself in that position, like put yourself that you're in a lab, you're doing all these things. Okay, you read it and you understand it. Okay, it is the example of thermal decomposition reaction. Okay, this is the example. After reading the activity, you go through this example which I just wrote. Okay, because I don't want to read everything on my own. Okay, the syllabus is too vast, so I want you to go through on some activities on your own, because I know that these activities are quite simple and you can do it on your own. All right, if you read it nicely, okay, you can do it on your own. So after reading this activity, you can come through this example. Okay, so I already wrote here what is important. Thermal decomposition reaction definition is important, examples is important. Okay, at the most 3 examples you remember. All right, for each reaction. Okay, it will come in the exams. Okay, this is another type, endothermic reactions. I already told you about exothermic reactions yesterday, right? Exo means out and thermic means heat. But endo means what? Inside, okay? And thermic means heat, all right? So here the basic definition of endothermic is all chemical reactions that proceeds with the absorption of heat are called endothermic, with the absorption. Absorption means taking in, all right, inside, you see, taking in of heat. All chemical reactions that proceeds with the absorption of heat are known as endothermic reactions. Okay, what is exothermic reactions? All chemical reactions that proceed with the liberation or with the giving out of heat, okay, is known as exothermic reactions. Okay, then you check the examples from there at the most, okay, from here at the most 2. Okay, you check 2 examples from the book. All right, then we come to the next type of chemical decomposition reaction, that is photo decomposition reaction. Okay, remember this. When I say photo, right, it always means it always means light. Okay, when I say photo, it always means light. And decomposition, you already know, breaking down. Right? So the basic definition of photo decomposition reaction is when a chemical compound decomposes on absorbing light energy. That is, it can be from the sunlight or from a bulb. Alright? So when a chemical compound decomposes on absorbing light energy, okay, so as to form two or more substances, just like the decomposition reaction. Okay, but here it uses light instead of heat. Here it is heat, here it is light. Right? Here the first one is thermal, which uses heat. It decomposes, it separates one huge molecule of compound into two smaller or three smaller pieces by using heat, but here by using light. Okay, so the basic definition is when a chemical compound decomposes on absorbing light energy so as to form two or more substances, elements or compounds, then the reaction that takes place is known as a photo decomposition reaction. All right. So let me tell you about this example. I'll discuss. Okay, I'll discuss this activity 1.7. So suppose I take silver chloride. Okay, silver chloride is a type of salt. Okay, which we cannot eat. Okay, but it is a type of salt. Okay, silver chloride is also present in bottles. All right. So you keep yourself again in a lab. Okay, I always used to do this. I put myself again in a lab, and what happens? I take two plates. Okay, I take these two plates. Okay, like glasswares. Okay, it is in the form of glass, but it's like a plate. Okay, like a saucer where you used to drink tea. All right, so in those two you take just one plate. I'm sorry, you take one plate, and in that one plate you pour silver chloride. Okay, that is AgCl2. Silver chloride is represented by the symbol AgCl2, silver chloride. All right, then what do? You put this out in the sunlight. Okay, that plate, you put it out. Suppose this is silver chloride here. You put that plate out in the sunlight. All right, after keeping it in the sunlight, okay, you will observe that the silver chloride that was white in color. Okay, silver chloride, I told you, is a type of salt, right? So obviously it is white in color, right? You will observe that after keeping this in the sunlight, which was white in color, okay, you will see that it turns silver. It turns silver in color. Okay, so why do you think this is so? All right, this is because as soon as the silver chloride, right, was exposed to the light, okay, it decomposes. That is, it breaks down into silver and chlorine. Okay, it breaks down into silver and chlorine, and as you know, silver is silver in color, right? So obviously it will show that it is silver in color, and this chlorine leaves in the form of a gas. Okay, it leaves away. All right, it goes away in the atmosphere, in the air, right? So the chlorine that was trapped in silver chloride leaves after it was exposed to the light. All right, after the silver chloride was white in color. It was kept in a bottle, it was okay, it was still white. But as soon as it is exposed to the sunlight outside, all right, what happens? It turns into silver color. Why? Because only Ag is present. Okay, and the chlorine that was present in this one, it leaves. Okay, therefore you have only Ag and the chlorine gas. Right, so see, this one is Ab and this one is Ac. This is also decomposition. Ab, silver chloride. Now it has only A. Right, so just like this one, you see this one, this representation AB gives you A plus B. Here also is the same. Okay, next we will go on to the third type, that is electrodecomposition reaction. By the name also you can make it out. Electro, what do you mean? Electricity, right, or electric current. Okay, electrodecomposition, that is decomposition of that compound into two or more simpler elements or compounds by the use of electricity or electric current. Right, so let's read the basic definition here. Decomposition reactions that takes place with the absorption of electric energy are called electrodecomposition reaction. Okay, so we use electric current here, okay, to decompose. All right, that activity 1.8 you can read on your own again. All right, it's not that hard, it is easy to understand. Okay, you read that. And if you have any problem, you tell me. After reading the activity, you check this equation. You put this equation as example. Okay, see, whatever I've written here, this is very important for your exam point of view. Okay, chemical decomposition reaction is of 3 types, right? Under that, you have this definition, you have this representation, examples, right? Examples here, I'm giving just one, but I'm telling you, you need this 3. Okay, under this, you have thermal decomposition. Under thermal decomposition, you have the definition, examples. Just here, I just gave one, but you read 3 examples. Okay, then endothermic reactions, then you read the examples 2 for this. Then this one, I wrote here example, but you need to read 3 examples from here also, and here also 3 examples. Right, I gave you one. Okay. So do you see here electric current? It's using electric current here. Okay, here it's using light, and here it's using what? Heat. So this one is thermal decomposition, photo decomposition, and electro decomposition. All right. Next, we will move on to another one, the 3rd type. Okay, I already discussed the first type, the second type. The first type is chemical combination reaction. Second one is chemical decomposition reaction, and third one is chemical displacement reaction. So what do you mean by displacement first? Displacement is when I tell someone, right? I tell someone from the first bench. Suppose this is a first bench. This is a second bench, okay? Suppose this is Prince, okay? And this is Karan, right? Prince and Karan, and this is Pranay, all right? Okay, so displacement means I'm asking Prince to go here and Pranay to come here and Karan to go here. Okay, so you guys are interchanging places. Okay, you are displacing your positions, right? From the first bench, Prince now has to go to the second bench. Pranay from the second bench has to come to the first bench, and Karan, which was in this corner, now has to move here, right? So you are displacing the positions, right? So that is what you mean by displacement, all right? So the basic definition of displacement is when a more active element displaces a less active element from its aqueous ionic compound, the reaction takes place is called a chemical displacement reaction. Okay. So suppose here, this is the basic presentation. I told you it displaces, right? Forget about these, okay? Forget about the definition also. Let me just explain to you the basic definition first. Okay, so do you see AB here? Do not see this, okay? Do not see this. So AB plus C, right? So this is Pranay, Prince, and Karan, right? Now in the second bench, first there was what? Karan, Prince, and Pranay. Now it will be Karan and Pranay, and Prince will go up, right? Right, this is Pranay, okay, and Prince will go up, right? So here similarly, they were in this bench, right? The first bench, this is the second bench, but now this one here, which was in the second bench, will come to the first bench, right? And this one here will go to the second bench. This is what they mean. So AB plus C gives you CB. So you see this AB, instead of A here, now this C will displace this A. You understand? So this is CB plus A. Okay, so now that you understand the basic definition of what displacement means, now I'll make you understand what chemical displacement means. Okay, so see here, AB, right? It is a compound of less active element A. Okay, so okay, so in here, this A is less active. Okay, I'll tell you what do you mean by active and not active. Okay, so this element A here is less active. All right, B is okay. So this compound, because A is in combination with B, okay, and it is less active, therefore this whole compound becomes less active now. Okay, so compound of less active element A. All right, then C, more active element. C is a more active element. All right, so now what happens? Because A is less active, B is okay, right? And C is more active. So what happens? C will now go and combine with B, because B is okay, right? This is very less, right? Very less active. This is very more very active, right? So it will go and combine with B. Okay, and A will go out. Now, since C is combining with B, now this compound of more active elements. Now, both these compounds are very active. Whereas A, which is very less active element, is displaced. Okay, the element which is very less active will get displaced. You understand? I'll tell you what do you mean by less active and more active, but the element which is very less active will get displaced. You remember this. Okay, so the element which is very less active will get displaced. Similarly here, A and B. A is very less active, so C is very active, so C will go and combine with B. Now this becomes a compound which is very active, whereas B, which is A which is very less active, will get displaced. Okay, so here I'll tell you about active and less active. Okay, because of that activity and less activity, now we have to read about the activity series of elements, okay, in decreasing order. Now tell me, what do you mean by decreasing order? Decreasing order is always from big to small. Okay, decreasing order is always from big to small. Okay, so now in this activity series, if you turn to page 204, you will see the activity series of metals. Okay, meaning how active they are, right? When combining with other metals, how active they are. Right, so who tops the chart? Who tops the chart there? It is Li, that is lithium. Okay, after lithium you have what? Most reactive is lithium. Okay, after lithium you have what? Potassium. Okay, that is K. All right, potassium is K. Okay, and the least reactive that is present towards the end is Au, that is your gold. Okay, Au is your gold. All right, you check this activity series, because according to this activity series, it will get displaced, this one. Okay, it will get displaced. Because what happened? Element which is very less active will get displaced. Okay, so will potassium get displaced easily? No, because potassium is very reactive. Alright, the element which will get displaced easily is gold, which is present at the bottommost. The element which will get displaced easily is what? Gold, which is present at the bottommost of the activity series. So I want you to read the activity series and this one. Okay, so K is the most okay, let me just first you check the activity series. All right, in the decreasing order means from big to small, that is from reactive to least reactive. Okay, and then you will check the rules for chemical displacement reactions. Okay, so the rules are: a metal higher in metal activity series displaces a metal lower in the metal activity series from its ionic compound and its aqueous solution. This I already told you, right? In the rule, this is the rule which I already told you. So elements which are very active, right, like lithium and potassium that are present at the top of the activity series will displace element at the lower or the bottom series, that is silver or gold. Okay, so you see this. This is very important. Okay, it's given in your book also. Please check nicely. This one you remember. Potassium is more active than sodium. Sodium is more active than calcium. Calcium of magnesium, aluminium, zinc, iron. This is tin, lead, hydrogen, iron, copper, mercury. This is silver and gold. All right, the activity series goes like this. So the more activity, highest element of activity series will be this one, okay, and this one. Suppose there will be two elements. Okay, suppose taking the example of this, there will be two elements, calcium and magnesium. All right, what do you think will displace what? Okay, calcium being in front, okay, meaning the more reactive than magnesium will displace magnesium. You understand? So suppose here if there is calcium chloride plus magnesium. So this, magnesium chloride plus calcium. So this calcium will displace this. Okay, it will displace the magnesium because calcium is more reactive than magnesium. Okay, wait, let me just write that again. Let me write that again. Okay, so suppose you have what I told you, calcium chloride, CaCl2 plus magnesium. Okay. Oh, sorry. Again, I made a mistake. Right. So suppose you have magnesium chloride plus calcium. So this calcium will now replace this magnesium. Why? Because calcium is more reactive according to the activity series than magnesium. So the result which you will get is calcium chloride plus magnesium. Okay. I hope so you understand this. And I want you all to read the activity 1.9 on your own, the examples and everything. Okay, you choose 2 examples from there: copper sulfate, copper nitrogen. Alright, and then in activity 1.10 also you read on your own. Okay, they are not that important, but then I want you to read on your own. Take two examples from each. Okay, take two examples from each and read on your own. Activity 1.0 or 1.10 and 1.9. Alright, so you do that on your own. Okay, and the most important thing, exercises 1A, I know all of you have done. Okay, for number 5, all of you have done, right? So most of you have, some of you have already finished 1, 2, 3, 4 also. So I want all of you to do exercise 1A, 1, 2, 3, 4 and 5. Finish this and write it in your copy, because without writing you won't get the notes and you won't get the answers right. Even if I'm explaining this much, you won't write anything in the exams. I mean, you won't write anything in your exercise copies. You won't be able to write any definition in your exams. Okay, so I want you to write your homework, exercise 1A, all the basic definitions, all the questions that are being asked, and if you do not get the answer, you ask me. Okay, so homework, you do this, and the activities which I already told you to read. Alright, activity 1.9 and 1.10 also read on your own. Alright, so that is it for today. Tomorrow I will be continuing chemical double displacement. I thought of finishing today, but then it's too much. And then we'll do oxidation reduction reactions, which is very important. And then we're almost done. Right. So you read those activity on your own, okay? And then we're gonna do this on the next class tomorrow, that is. Okay, thank you.